Alright, so this is my interaction design project. It's called the Augvox. It's an augmented vocal instrument, and basically what it does is it uses 4 FSRs, an ultrasonic sensor, and a joystick, in conjunction with a microphone to alter the sound of the incoming signal. So basically what I want to do with the video is just give an overview of the instrument itself and give some examples in Maximus P just that I can't do in the paper. So basically, this is the instrument itself. It's got the 4 FSRs all flush on the body in position such that the fingers can rest comfortably on them, just like that. And the joystick is sunken into the body just below the thumb so that you can operate it easily enough. The ultrasonic sensor picks up the distance from the right hand to the instrument, and just this little LED there just reflects that with a change in colour from light green to very bright red, depending on the distance. So I'm just going to give a few examples in Maximus P of what the instrument actually does. So basically, the 4 FSRs are used to spell out a binary number, basically, so that you can transpose the sound by that amount of semitones. So 1, 2, 3, 4, 5, 6, 7, 8. Let's do this. So this is the least significant bit going up. Alright. Okay, so I'll just start that. So basically what that's doing is going through a PV tuner, which is part of the FFT's library, and it's transposing the original signal according to the amount of semitones that I've said, which is say 1, 5, whatever, and then it's putting it through just a scale, which is a minor scale. And what I do as well to transpose, that's transposing up in semitones, and if I want to transpose down, I just push the joystick button in, that lovely noise, and do the same thing. So what you can also hear in there is the original input from the microphone, and if you want to turn that off, just flip that switch down so that then you just have the effective output. Okay, and just some things that say that the FSRs do is the more pressure you put on the FSRs, if you put a lot of pressure on, it'll start to distort. So it's big crushing coming in. So that sounds good. And then if you put a low amount of pressure on, the EQ drops down, and there's a kind of a lower sound. Okay, so just what the actual joystick does is the horizontal axis controls the frequency modulation that's involved with the transposed input, transposed stream of the audio. So if I push to the left, there's less harmoniously a lower modulation index, and there's more dry mix, and if I push to the right, it becomes more open, and there's a lot more harmonics, and it kind of manifests as feedback kind of sound, so it sounds like this. So hopefully you can hear the difference there. The vertical axis then controls delay parameters, so that there's a set amount of delay here. But as I increase, as I go up, there's much longer delay, so the sound drags out longer. And there's a longer tail on the sound, and as I bring it down, it's much more dead. So basically, these are acting as what I'm calling the harmonicity, the amount of harmonics, and the sustain. Okay. What the ultrasonic sensor does is it freezes the sound that's coming in from the transpose stream, and then you can take that sound and slow it down to a point where it's not moving at all, or else you can play it at its normal playback rate. So basically it takes 1 second of sound once I move over the sensor, and then I can stretch them. Clear that by just facing it away from me. So I'll just give a quick demonstration of the whole thing again.